Welcome to Math 108, Module 15.3, something called the rational exponents. So before I explain this, I would like to go back and review on some of the other exponent rules that we talked about before. All right, so as you can recall, the different exponent rules, we can have exponent for 1 for any real number a. Okay, for any real number a, when you don't see an exponent, it's automatically assumed to be 1. And as you can recall, when the variable has exponent 1, that's considered as linear. 0 exponent for any real number to the 0 power is always going to be 1. All right. Product rule, remember the product rule, when the base are the same and the base are multiplying, we can add the exponents. Quotient rule, when the base are the same and the base are dividing, we subtract the exponent. And remember now, it's always the top exponent subtracts the bottom. Negative exponent rule, remember negative exponent rule says if the base has a negative exponent, we got to flip it to the other side of the fraction. All right, power rule, when you see one term inside the parenthesis and there's an outer exponent on the outside, we would just simply multiply the exponents. All right, and we got power of product. Okay, it's basically same thing as power rule. The word product means if I have multiple factors inside the parenthesis, again, it's only one term. The outer exponent will multiply all the exponents in the inside. All right, same thing with power of quotient, or where my A and B, okay, is dividing. Again, by being part of the power rule, the outer exponent will multiply the exponent on the A and the B. So let's take a look at this thing called the rational exponent and negative rational exponents today real quick. So basically, the general form for rational exponents, basically now my exponent is a fraction. So when the exponent is a fraction, for any real number a to the m over m power, okay, it actually means the denominator of the fraction determines the roots. The numerator, okay, tells you the base inside the radical is raised into that power. All right. So the numerator becomes the exponent for the base that's inside the radical. Denominator is the roots. Now another way of writing the same thing is basically saying, rather than have the m power that is on top of the base inside the radical, I can actually write the numerator m, that power, on the very outside as well, like this way. Okay, the two is actually saying exactly the same thing. Okay, so basically fraction exponent becomes a radical. All right, so for example, I'm going to show you how to do this in the calculator as well. Okay, but let me kind of explain this using the rules. So now my 16 over 49 whole thing to the half power. So the half power means the denominator determines the roots. So right away I know I have a square root. My numerator is telling me my base is going to be raised into that power in the inside. So 16 over 49, if I say whole thing to the first power like this, that was still going to be 16 over 49 in the inside. All right, so now remember back in module 15.2, we talk about radical can be split in, when I have a division inside the radical, I can split into two separate radicals. So we can do that here as well. So I can say this is square root of 16 over square root of 49. So that's why my answer is going to be 4 over 7. Okay, so if I will enter this in the calculator, we just got to be a little bit careful. Start out with a parenthesis, 16 divided by 49. All right, exponents, the caret key, raised into the half power. So I'm going to put, so if your calculator shows a little box on the top, you can simply type in 1 divided by 2. Since my screen looks slightly different than yours, I'm going to put my 1 divided by 2 in the parenthesis. So that will give me my 0.57 something, convert to a fraction. Okay, and we talked about this before. Decimal has a repeating pattern, which is 5714 14285. See right here, 5714285 again. And these kind of repeating pattern will convert back into a fraction for me. All right, let's try another one. Okay, I'm gonna do this one by hand real quick, and then I will show you how to put it in the calculator, so you can kind of get a sense of why the answer is the way it is. So this one is a cube root. So denominator determines the root, so I have a cube root so far. And my base, 27 over 125, is going to be raising to the second power. The numerator means the base is raising to that power in the inside. So for this particular problem, I can write 27 over 125 whole thing to the second power this way, or I'm actually going to purposely write it where the whole thing, the whole entire radical expression is going to be to the second power, because I want to evaluate my cube root first before I'm going to square it. So again, knowing that 27 and the 125 inside the same radical can be split into two parts, so we can just kind of do it just by looking at them. Cube root of 27 is going to be 3 over cube root of 125 is 5. So now this problem inside the radical becomes 3/5, but the whole thing is still to the second power. So 3 squared is 9 over 5 squared is 25. So the answer will be 9 over 25 because I basically evaluate the radical first before I square them. So if I put this in the calculator, 27 over 125, close parenthesis, raising to, parenthesis again, 2 over 3. That gives me the same answer. All right, 9 over 25. All right, so kind of explain to you. All right, change the following equivalent, change the following expression to an equivalent expression in radical notation. So I need to write this fraction exponent into radical notation. So again, assuming all variables are positive. Remember I mentioned that back in 15.1, saying the principal square root should be a positive answer and the negative ones. So often we will always trying to assume all the variables are positive because we just want to look at one of them rather than both of them. So denominator determines the root. So basically I have an 8th root of x to the 5th power. Numerator tell you the base is raised to that power inside the radical. All right, so just a quick brief introduction on the rational exponent that turn out to be radicals. Okay, fraction exponent become radicals. In the next video, we will begin to apply all these exponent rule together that's involving with fraction exponents. All right, that will conclude this lecture video. Thank you for watching.